Continue from previous video where we like to find the design wind speed. We have so far calculate some portion of the site wind speed. We are MD, MZ, CAT, MS and MT. So we are substituting the regional wind speed 45 meter per second that we calculate in the previous video. That is we are 45 meter per second. MD we are going to find it. MZ CAT we found 0.91 that we found in the previous video where we found MZ CAT 0.91, and we also find MS and MT as a 1. So that substitute the value, the calculation gives 40.95 MD. Now the MD has a various values, probably one of these 1 2 3 4 5 6 7 8 values, so different 8 values. So for the site wind speed we have and we are using this short form 40 point for the site wind speed site with a B we using short form 40.95 MD. So MD is MD we can find in section 3.3 on page number 16, which is on the page number 16 AS NZS 1170.2 2001, where in table number 3.2 we have various value of the wind direction multiplier MD. So in our case we have region A2 for Sydney, that is given in the questions. Sydney, the building is located in Sydney, and if I draw this figure here with the 8 different directions, north, south, east, west, and northeast, southeast, southwest, and northwest, we can find that for region A2 various value is given for north, northeast, east, and southeast, and so on. So we can just copy those value here. For example, north I put 0.8 as a MD, northeast 0.8, east 0.8, southeast 0.95, southeast 0.95, and so on. That is I copied from this table. Now once you find the MD value, we can substitute that MD value in the equations. V side beta is equal to 40.95 MD that we just found here, 40.95 MD. That 40.95, if you substitute different MD, substitute the MD value into V side beta 40.95 MD. So if 40.95 0.8, that we found 0.8 for north from the table number 3.2. So 0.8 respectively. If you substitute the MD value in these equations, we can find 8 different value of site wind speed where beta is n. Like for examples, if you want to say that site wind speed for north, you can say that 32.76 meter per second, for example, for this case. Similarly, we can say the site wind speed for northeast, that beta is 8 different value from north, northeast, east, and so on. So that will have a, let's say 32.76 meter per second, and that will continue here. So that's the meaning of the small beta, 8 different directions. Now the building is oriented at 30 degree from the north as given in the questions. If I can show it in the questions, that questions given that the building is oriented 30 degree from the north. So orientation is given here, building is orientation 30 degree. Now we need to find the orthogonal wind speed, like what is the wind speed coming from here, what is the wind speed coming from here, what is the wind speed coming from here, what is the wind speed coming from here. That was given in the Australian standard. If I can show it here in the Australian standard, it's given here, building orthogonal design wind speed V design beta on section number 2.3 on page number 8. It has given these 3 lines to explain how these orthogonals work. So we just need to find these 4 orthogonal directions. That's what we are looking for, and it should have a maximum cardinal direction side wind. So we need to find the maximum value among these 4. Now how we gonna find these values? So that is explained it here. Now here what I done, that I put this black line that we just found it. Now this red dot line, it's just the orientation of the building. So if I can show it here, that line which is this line, 30 degree to the north, is drawn here, right? So that is first things, and perpendicular to this one we draw this one, that is orthogonal direction. That's the buildings here. So you're interested in finding that wind speed coming from here, wind speed coming from here, wind speed coming from here. Now from this line we need to take the 45-degree sector. So this blue line is drawn 45 degree to the left and 45 degree to the right to get the plus and minus 45 sectors. That is given in the Australian standard. If I can point it out here, that here they have given that cardinal point within the sector 40 plus or minus 45 degree to the orthogonal direction. So that sentence is explaining here that we need to take 45 degree plus 45 degree minus 40 case. Now we know the values here and here, so we need to interpolate these two wind speed to get this value. For here, if we interpolate these two, we can find this one, right? So that's the mathematical step. Now for examples, if you finding this, we need to take the maximum value between these two. So to be logical here, if I can see here the interpolation between 32.7 and 32.7 would be 32.76. If I look at here, that would be the interpolation between 32.76 and 38.90 would have more value. So here the answer is 32.76, but there are something more than 32.7 if you interpolate between these two values. So it is logical to the interpolation here. So the interpolation is given here. For examples, if I can just show it how I done it. So let's say this is the reference 0. So 0, that is theta 0, 32.76. X is 15 because we need to find this 15 because we know 13 and take it 45 sectors that give 15. So 15, and we need to find the velocity here 45. So there's a 0 line, so that is 45, and the velocity 38.90. So this is the interpolation equations. Y equal to y1 plus y2 minus y1 times x minus x1 over x2 minus x1. Substitute the value. 32.76 is the y1 plus y2 is 38.9. Take away 32.76 times x is 15. Take away 0 x1 over 45 minus 0. That calculations give 34.80. So the first theta equal to 0, we found 34.80. That is we found 34.80 in this case. So that value is 34.80. That is the maximum between this one. So if I interpolate here, that will give 32.76, and this gives 34.86, and the maximum between this and this will give us this value. So it's the maximum value between the sector of plus or minus 45 degree. Similarly, we need to repeat the procedures for this case that we need to take the 45 sector plus and minus, 45 sector plus and minus, and we need to find these 4 different velocities. Now in here we are now working for this case. Now if I take the 45 sectors here, 45 sectors here, logically we are looking for this one and this one. So let's compare here. So interpolation here, that gives us 32.76 meter second. Here that should have a some more than 32.7 because the interpolation between 36.86 and 38.60 will give you the more value. So it is logical to do the interpolation here. Now for this case, we again use x1, y1, x0. So take the reference here, 0, 36.86, that's the angle. 15 degree from here, so that is 15. We need to find the velocity here. x2, 45 degrees, so 0 to 45 degree, 38.60. That's the interpolation equation. Substitute the value, which is 36.86, which is y1, plus y2 is 38.6. Take away 36.86 y1 times x15. Take away x10, x2 is 45. That's give us 37.44. So that value here will give us 37.44 meter per second. Now that is the we need to take the maximum between 37.2 and 32.76. So that is 37.44. We found it here, and now we need to find between this and this in the third case. Now here we can simply use the same diagram. Here we have 45 degree here, 45 degree here, but then we can check logical 36 and 36 and 38.39 and 40. So the maximum value will falls here. So the interpolations will be given between these two, 40.90 and 30.90. Take the 0 here, which is, so let's say the angle 0 is here, 45 degree here. So this is your x1, y1, x2, y2, and this is 15 degree here, that is your x, and we need to find the y. So that's what I'm doing it here. Substitute the value. Interpolation gives 40.27 meter per second, so that comes here. Now for these sections we need to find here. So the interpolations between this and this, and the interpolation between 40.95 and 30.96, so we will get the maximum value here. And the interpolation for these sections is given here for this particular case, 38.90 and 40.95. let's take the 0 here, so x1, y1, x2, y2. Let's take 45 degree here, which is x2, and this one is y2. And similarly you have 15 degree and y we need to find for this case. That will give us 40.27 meter per second. So finally we can put all the values here that we found it, and the design wind speed, this theta is vary from 0, 90, 180 and 270. that is 0 here, 90 here, 180 here, 270 here, right? So we have 4 different value: 34.80, 37.44, 40.7, and we need to select the maximum value between this. That is your design wind speed for this case. So for the next steps in that wind loading calculations, we should use this design wind speed for the all calculation, which is 40.27 meters, because this is the critical one. Our buildings will experience this is the wind loading, which is 40.27. that is the maximum wind load coming from these directions. Thank you very much.